The good news is
Because dividing is multiplying by those quickly. So there's
okay. I did not specifically talk about the textbook, right? I think I did send an email, but I think we will talk about our textbook as well. It's very important. In fact, every single thing that we will be covering, if you go page by page, we are actually covering the book, but covering the book in a very smart way, because one semester we cannot cover everything. So we will go very smartly. Yes. Should we start? Oh, that's not good. This is color issue. Okay, we have 3 minutes. So right after this, we will talk about the physics 1 cases as well. That exactly when we would use the physics 1 formulas. Physics 1 is the right name of the course, right? It was physics 1 in which you studied the basic dynamics. Okay. So constant acceleration, we will be covering that as well. I think I can start just writing our case 3. And case 3 part B is delta S is given / asked in the problem. Okay, that's good. Life is good right now. Tahshin Chan, you can hear me, right? If you can just confirm, please. Sorry. Oh yeah, of course, of course. Oh, Tahshin Chan, can you hear me? If you can please respond. Oh, Tahshin Chan is not responding. Oh, I don't. Oh, I don't. This means there's a problem in the speaker. Oh, that's why. Hello. Oh, okay. I think that's why. Okay. Now, Tahshin Chan, can you confirm? Okay. Oh, you can hear me now. Good. Okay, good. Okay. Okay, everyone, let's start. So we were talking about these 3 cases of acceleration, right? The case 1 was when acceleration was a function of time. The second case we talked about when acceleration was a function of position. Third case I am going to talk about right now. Now, what is the example of acceleration as a function of position? In very simple terms, if you remember, we did do this problem. We have these 2 plates. Electron goes right into the center. It will accelerate as it goes towards the positive plate. And somebody else told me that acceleration is equal to 4 multiplied by position. You remember that from your last class, right? And then we said, how can we solve it? We started solving it using the case 2 methodology. Now, just remember that your practical cases are not as simple as that. For example, a rocket launch, a rocket is accelerating. Is it a function of only position? I don't think so. It's definitely a function of position as well as time. So we are not talking about the complicated cases in which acceleration is a function of time as well as position, or are you getting my point? We are just talking about very simple, nice, beautiful cases. Acceleration is a function of time, is a function of position, case 2, is a function of velocity, case 3. Now, let's say I give you a problem in which I tell you that there is a point object and its acceleration is 3 multiplied by velocity. How do you approach that? Well, you will have to see whether I am asking you time in that problem or I have given you delta t. The second case, subcase can be if I am talking about the change in position of that point object, or I'm asking you to find change in position. So let's talk about the subcase A. What's your intuitive guess? What should I do? If I am going to find delta t, I think all of us agree that I should write A equal to dv by dt and I should play with it, right? Now, what should I do? I will have to start playing with the dt, right? So dt equal to dv by A. Does it make sense? Oh yeah, it does. Because this acceleration is equal to 3 multiplied by velocity or something's a function of velocity. And I have a dv sitting on top of that. It surely makes sense. So I will use a purple marker. T1 to T2 integral. Okay, any guesses about the limits?
V1.
Yeah, V1 to V2, right? V1 to V2. And I have to stop here. I cannot proceed, right? Now I have to give you a question, only then you can proceed. Okay, let's talk about the second case. But this time I would want you to think about it. Use your imagination. If it's delta S that is given to me or asked in the problem, can I start from here? I don't think so. You cannot. So what should I do? There is one thing I really want you to remember. Last time I did not emphasize enough. By the way, anyone who wants to make a guess? Yes, say that one more time. ADS equal to VDV. Yes, that was the right answer. This is one formula that all of us will keep on forgetting, and this was the right answer. Done. Now all you have to do is just start playing with it. Look, now A is a function of velocity, so it makes sense. ds, oh, we have somebody who's okay. ds equal to boom. Question is a game over. Do an integral, boom, and then I have integral v dv over A. Is it visible? Yes. So what will be here? There will be S1, S2. I really have to squeeze, by the way. Then here I will put dv. So I will put a v1, I will put a v2. Does this make sense? Okay, let's see whether it makes sense or not. A is a function of velocity. So consider it as a 4 multiplied by v, okay? Make your life easy. I will put a 4 multiplied by v here. I have v here. Let's say I have v here. I'm feeling happy. I have a dv here. So I surely can integrate. A equal to 3v square. I will put a 3v square here. I have a v here. I have a dv here. I can solve the problem. Okay. Make sense? Right? So 3 cases. Acceleration is a function of time. That was my case 1. Acceleration is a function of position. That's my case 2. Acceleration is a function of velocity. That's my case 3. Delta is given or asked in the problem. That's my sub case of case 3. Delta S is given or asked in the problem. That's my second case. So far, so good. Okay. Oh yes, absolutely. Please. So you can all join the class whenever you want. Okay, no worries. Okay, 7654321. Now I will talk about physics 1, because if I don't talk about that, with the experience of teaching this course, I can assure you one thing. All these cases I'm talking about in a pressure situation in an exam setting, when you are just, there is just time that is clicking, many of you will want to directly write the formulas of physics 1. Please don't do that, because those formulas are my special cases. So I have acceleration equal to constant. That's my physics 1. Okay, here comes, this is my nice and beautiful plot. Now you will start seeing our physics 1 formulas. Okay, acceleration is equal to constant. What should I do? A equal to dv by dt. I always do that. A is constant or not. Okay, now I will say it's physics 1. So I will say it's constant, const. And I can say, I'm going to remove the arrows, by the way. So it's const dv by dt. And all you have to do is take the dv on one side, a on the other side. By the way, why did I remove the arrows? Because right now I'm talking about very simple one-dimensional problems. If you come across problems and you have vector with I, j, k components, of course, then you will tackle it accordingly. Right now, life is very easy for us. What should I do now? Integrate? Okay, integrate. What about this one? Constant, pull it out, integrate. So I will skip one step. Okay, what do I have? Delta V equal to A delta T, and I have A equal to delta V by delta T. Now, most of you are saying, where did we study that? In physics 1, right? So I will actually write it in the physics 1 form. In physics 1, your instructors used to write it like this: V2 minus V1 over delta T. And they used to write Vf equal to Vi plus AT. Does it ring bells? It does, right? So if I give you acceleration equal to 4 multiplied by position, you don't use that, because A is constant here in this expression, Vf equal to Vi plus AT. Okay, everyone, I will now name it as nice and beautiful case 1, equation 1. Now, should I make some, I did not make any plot. Okay, I will leave the plot for later. Okay, one more case. A ds equal to v dv, right? So cram it, memorize it, ASAP, A ds equal to v dv. Okay, again play the same game. Pull out this A, because it's constant, do an integration equal to v dv, and I'm stopping. You do it yourself. A is constant. Tell me, how do you arrive? Okay, so you can just tell me right now. Right hand side. What will be the right hand side if I perform the integration? Huh? Huh? Yes, 100%. So A multiplied by, so I will not skip any step. Integral of ds is a s. I will substitute s2 and s1. So I will get s2 minus s1. One of the students said, perform the integration. Integral of v is v square over 2. Put a little beautiful bar, v1 to v2. A delta s equal to v2 square over 2 minus v1 square over 2. Correct? Then I get 2, does it ring bells? 2as equal to vf square minus vi square. Yes, no? Yes, right? It does ring any bell. It does ring bells. Now, in a pressure situation, I tell you acceleration equal to 3t square, 3 multiplied by time square. You don't use this formula because this formula is for a constant acceleration. When acceleration is 9 meter per second square, when acceleration is minus 2 meter per second square. So I will put a 2 here. Nice and beautiful. So far so good. Okay, I should make some plots. Okay, I will do it later. Okay, let's do it one more time. The same game one more time. Let's do it together. This time around, okay, I don't have space right now. So take 2 minutes. Then I will go to the next slide. Should I? Okay, 6, 5, 4, 3, 2, 1. I will play the same game one more time. Plots are later, okay? A ds equal to v dv. Don't forget that. Let's do it. ds equal to v dv over a. Where did the vectors go? I just removed it for my own convenience. Now, I will perform an integral ds. Okay, let me please save a little bit of my time. So I will put a beautiful S1 and S2, and then I will put a beautiful V1 and, oh, okay. Should I put V1 and V2? Yes, because it's a dV sitting there, right? So V1, V2, and boom, I have S. Okay, integral 1 is S, then I substitute S2 and S1. What about this one? Anyone? Because you pull out the A, it's a constant. I have told you. Then integral of V is V square. Then I make the substitution. Did I miss the 2? Yes, I think I did. Oh, what am I doing? I'm doing the same thing again. Sorry. We have already done that. I will actually this time, instead of V2, I will write VF equal to VF is equal to VI plus AT. So V2 equal to V1 plus AT instead of V2. I will write 1 over 2A V square and I will put a V1 and V1 plus AD delta T. Everyone is clear, right? Instead of V2, I am writing from the previous slide V1 plus A delta T. Now I will write S2 minus S1 equal to, is just some crazy maths. We will have a V1 plus A delta T square minus V1 square. You do the maths and tell me the expression. In general, derivations are not included in exams, but it's a good practice that I just tell you the final formulas by this method. Just tell me the final formula. Okay, I will do it. Yeah, you got it?
Yeah.
Yes.
I remember S2 equals, or delta S equals to
Yeah.
V1 plus sorry, V1 times delta T plus 1.5 A T square.
Got it. Good. So let's do it together. Delta S equal to, thank you, 1 over 2A. Then I have V1 square plus A square delta T ka square plus 2V1 A delta T minus V1 square. As one of the students said, I will remove this and nice and beautiful. I have S equal to, oh, what is this? Did I make a mistake? A square delta T square over 2A plus 2VIA delta T over 2A. And I have Why don't you all double check now? Right. S is equal to VIT plus half AT square. Is it correct?
Yes.
Correct, right? Looks to me correct. Boom. We have one more equation of physics 1 that if you remember, you used to remember. I gave you acceleration equal to 3 multiplied by time. You don't use this one because this is for constant acceleration. Done? Okay, one last expression that I really want you to remember. This one is a little crazy because we usually don't talk about this expression too much, but I still emphasize on this one. So I have velocity on y-axis and time on x-axis. How does constant acceleration look like? Actually, this is how constant acceleration looks like. It's a nice and beautiful, let's say, a straight line. Okay. And if it's a constant acceleration problem, I tell you that this nice, beautiful point is my V1. Nice. And it is sitting at T1. And then I have another nice point. It's my V2. Is it a constant acceleration?
No.
Yes, yes, it is. I will tell you why. I will tell you why. This is, I tell you, acceleration is because non-intuitive, so sometimes it's confusing. How is this a constant acceleration? I tell you a simple trick. Acceleration is dv by dt, right? dv by dt. And dv by dt is a slope, right? So if my slope is constant, my acceleration is constant. Is it a constant slope? Oh yeah, it is. So acceleration is constant. Now just imagine if I ask you, can you please give me the V average? All of you will tell me that V average is, okay, V is delta S by delta T. So let me first do it in this crazy way. V instantaneous is equal to ds by dt. V average is delta S by delta T, right? So I will use the razor and I will remove it. The moment I write that one, all of you would be like, why are you even doing this? Why don't we say it is equal to V1 plus V2 by 2. So that's just an extra thing that I usually cover in the classes, that for a constant acceleration problem, if somebody uses V average equal to V1 plus V2 by 2, then that's even fine. And that's why I will finish this by making a nice and beautiful line here. I will put a VAVE here, and that's your formula number 4. So constant acceleration, I have covered 4 formulas. 2as equal to vf square minus vi square, s equal to vit plus half at square, vf equal to vi plus at, v average equal to v1 plus v2 by 2. Good. Now, there are some plots that I really want to make. If you have any questions, please feel free to stop me right now. There are some plots I want to make because then we will do some nice examples. Okay, let me go back and make some, oh, where is it? Let me make some plots for you first. Where is it? This one, right? So acceleration equal to constant. Now I'm talking about dv by dt, right? So let me just write a equal to ft. Let's say, then a is equal to f of t. No need to write it. We already covered that. Just let me make that if, okay, this is an extra information, a equal to f of t. Let's say I have acceleration not constant. Right now it's not constant, okay? This is a nice and beautiful plot. Somebody said, what is the area under this? Can you please tell me what is the area under T1, T2? Okay, there are 2-3 answers, but I couldn't hear. So area under AT curve is change in velocity, right? So one of the students who's 2-3 students who said that, they said because acceleration is variable, a equal to dv by dt, they took the dt there, and that's why they said that this is dv that you are talking about. Nice answer, by the way. Okay, let me make another plot for you quickly before I go to the, should I go to the next slide? By the way, this is not acceleration constant, okay? Okay, let me make another nice and beautiful plot for all of you. And our online students can stop me anytime by unmuting the mic. So let me make another plot for you. Okay, give it a shot. So acceleration right now is a function of position. Again, it's not constant, okay? Somebody gave me S1. Somebody gave me S2. Can you please tell me what is the area under the curve? Huh? Say that one more time. Kinetic energy. We have a chat message. I think. Yeah, both of you are correct. The one student who replied in the chat message and the student in the class, both of them, I think both of them are pretty much correct. Let me just answer now. So it's A ds equal to v dv. So the student who in the chat message said v dv, sorry, ADS, I think you should integrate, and the student in the class is actually correct this time. So you have to integrate because area under the curve means I have to integrate. Once I integrate, the right hand side will be, we will have a v square over 2. So I will have a, what is that? V square over 2, v2 square over 2 minus v1 square over 2. Thank you. v2 square over 2 minus v1 square. Just one quick remark. Every time someone makes a curve and asks you what is the area under the curve, you don't need to necessarily answer that, but because many times the area under the curve physically doesn't mean anything. This time around, it does mean something. So that's why all of us answered. Okay, did I cover everything? Yes, I did. Well, on that note, let us get going. Let me ask our online student. Ahmed Dogu Khan, then we have Muhammad Hashir, then we have Kashin Chan. Should we continue? Okay, 6, 5, 4, 3, 2, 1, everyone. Thank you. I will start with our few examples, and you all have to do it with me, by the way. I really emphasize, please. This one is really interesting. You will love it. So I have this piston cylinder damper arrangement. This is an example. Use your imaginations. Now, just to be clear on the damper part, what is a damper? We use it in cars as well. Now, there are many different kinds of dampers. This one is a very simple damper that has oil in it. Now, I am making a couple of holes here. This is just horrible drawing right now. So let me make a yellow marker quickly. These are 2 holes. Nice and easy, 2 holes. And I have another hole here in the cylinder. The damper works something like this. You have this fellow. Okay. Now understand this one. You have a sudden jerk. What happens? The moment you have a sudden jerk, you have velocity of this whole thing, okay? So this is whole chunk. You have a sudden velocity with which this is subjected to because of a sudden jerk. You know, car is going, you have a sudden jerk. What happens is that this whole thing wants to move towards right, and you have lots and lots of oil here, oil, oil. This oil wants to go towards left through these two holes. So what exactly happens? You have a damping effect because lots and lots of oil wants to go towards left. Now, of course, you have a spring that is associated with this. So this is actually an oscillatory system. You know, it goes like this. 10, 10, 10, 10, 10, 10, 10, 10, 10. So definitely there is a spring that is working along with this damper. So again, imagine like this, you have a jug, 10, 10, 10. If you don't have oil, you will just keep on oscillating for extended periods of time. You want that oscillation to be damped. That's why you have oil. Now, somebody told me the basic mechanism is clear, right? Because the whole problem will pile up on this. Okay. Somebody tells me that this damper works like this, that acceleration is given as negative k multiplied by velocity. So I will put a beautiful velocity here, and I will say that the acceleration is pointed towards left. Let me use a nice and beautiful arrow, so there are no confusions. And this is the A. Okay, anyone who wants to tell us why A is equal to negative kV, where K is a constant? Why there is a negative? Because V is, acceleration is in the opposite direction. Right. Because even when the whole oil has come here, so acceleration is negative to the velocity. That's why this is deceleration. That's the whole point of the damper. Got it? And do you see this V that I have put here? I'm emphasizing that this whole chunk, this plus this whole chunk wants to go towards right, and the acceleration is towards the left.
So
yes.
Will be slow down.
Yes. Your question is so it can slow down?
The chunk will be slowed down.
Okay, let me, okay, yes, I will. Exactly. Right. Exactly, yes. But I will actually make a diagram. So although this diagram at this point, so it goes like this. Look, you see this thing, this thing. This is because of the damping. If you don't have this oil, this thing will go like this. 10, 10, 10, 10. It will just keep on doing this 10, 10, 10, 10, 10 for extended periods of time. You want this 10, 10, 10 to damp quickly. That's why you have oil and damper. Okay, now here comes the question that all of you are going to solve today. Surprise, surprise. Express velocity as a function of time. Okay, you do it. Do it. Let me open my notes, which are more clear. Let me use purple color here, or let's say this color. So this is a piston, okay, and then you have. So anyone who finds out the first step, they can just tell us what is the first step that they wrote. Yeah, it seems correct. So this is a piston that I'm making, and then this V is towards right, whereas A is towards left. Then I will also make a heading here that this is a beautiful center line. Let me use a yellow color. Oh, no, not yellow. Let me use a dark green color. This one shows me the reference line. I will put S1 equal to 0. Okay. And now we will start together. Okay, one of the students said A equal to dV by dt. No. Okay, I think it is correct. Then we have A equal to minus kV, right?
V3 is equal to V1 times E over minus K times W.
Say that one more time. V comes out to be?
V2 is equal to V1 times E over minus K times
Yeah. This. The answer is correct. Yes, you solved it. That's nice. Let's do it together. Minus K dt equal to dV by V. And then K is a constant, but I will definitely do the integration. Nice. Nice. Okay, what about the integral of dV by V? Natural log. Yes, you are correct. And I will do a minus K. Yeah, I will just go really step by step because this is our initial classes. Equal to natural log of V. I will put a bar V1 to V2. Then I will just change the color for my own convenience. Minus K, T2 minus T1. Natural log of V2 minus natural log of V1 can be written as V2 over V1. Okay, that's good. Okay, hang on. One quick remark. I have the stopwatch, right? So if I have the stopwatch, why am I making my life difficult? Let's put a 0 here because time starts from a 0. And one more remark is why T2? It just doesn't look fancy. Let's put a T. So minus K T minus 0 equal to this. So then you just take a nice and beautiful e power. Just one quick remark. V1, I will call it as V naught, and V2, I will call it as V. Probably in the beginning, I should have told you. So I have minus K e power minus KT equal to e power natural log of V2 over V1. And V comes out to be, as one of the students indicated, e power minus KT. Thank you so much. The answer is correct. Yes, please. Okay. Good. Seems correct, right? Okay. Everything is fine, right? Okay. So one quick remark. Why don't you all make a plot quickly? Plot is really nice. So make a plot with the y-axis as V and x-axis is T. What is your guess? Exponential decay is the right word. This is V naught goes with a this is the hardest part on whiteboard. Something like this. Good. So when the time is infinity, the V is 0, right? When time is incredibly big, the V goes to a 0. When time is 0, I have V equal to V naught. When time is incredibly big, because of minus, V goes to a 0. And I think life is good. By the way, just a quick remark. For this damper, what is the initial velocity? Let me put this way. Have you gone through that differential equations maths class till now? Yes. Everyone? Good. What is the initial velocity for this system? Huh? No, if you can identify with the symbols. So I have different symbols. What is the symbol for initial velocity? V naught, right? V naught is the initial velocity. So I should have specifically told you, but I did not, which was a mistake. So here you can put initial velocity is V naught. Okay. What about initial position, displacement, whatever? S1 is 0. Okay, another thing. Is this a forced system or unforced system? So how should I say? Do we have a continuously applied force on this system or not? No. This system is being driven just so it's not driven or a forced system. The fact that this fellow piston moves towards right is because of the initial velocity. So whenever you go through this speed breaker or through some pot of hole on the road, there is this jerk. That is that initial velocity V naught. Okay. So it's not a driven system, it's not a forced system. Why don't you do another thing then? Please tell me express. Okay, this is your next task. Quickly express the S distance covered as a function of time. Okay, whose S I am talking about? I'm talking about this piston, because remember that there is a spring that is also attached to it. So it goes like ting, then the oil is on the left. There is a spring, okay? Remember, this piston will also go back ting, then the oil goes right, then it goes like ting. So the ting, you get my point. So there is a certain S that is being covered in this motion. What I want from you is, why don't you tell me what is the S? Our online students, Ahmed, Togu Khan, Muhammad Hashir, and Tashin Chan. Please ask me questions. Please have a look here if you haven't started. Now, got it. Minus k v naught e to the minus k. S equal to minus
K V naught e to the minus k.
It's just one little mistake during integration. I think k will be in the denominator. Your answer is correct. Okay, so you all can join me in this one. S2 minus S1 equal to, okay, we still have students who are trying, so I will let everyone finish. Okay, V equal to What was that? V naught? E power, right? Okay. And why did I do that? Because I need to have a V in the form of a T. And fortunately, I did have V in the form of T. So I took that opportunity and I substituted here. And boom, game is pretty much over. And you have S1. Okay. You know what? Again, S1 is 0, right? So that's why I was a little clear from the get-go. And instead of S2, I will just write S, function of T, pull out the V naught. Okay, what about this integration? E power minus KT divided by minus K, right? With a little bar, with a 0, with a T. Boom, it's a game over. S, function of T, equal to minus V naught over K, E power. Okay, now you have to be careful. Put a bracket, E power minus KT, right? Minus E power minus K multiplied by 0, right? So why am I even doing it? Let's do like a 0 or minus 0. Minus 0 looks funny, but anyways, S bracket T equal to minus V naught over K. Then there is a E power minus KT minus 1. Oh, come on, it's not even ending. S bracket T equal to V naught over K minus 1 minus E power minus KT. Nice and beautiful answer. Okay, how many reached closer to this answer? 1, 2. So just remember, there was only one trick. That trick was what to do with the V. Okay, in a pressure situation, when the clock is ticking in the exam, we are very tempted to just pull out the V and just integrate the dt. Don't do that, because we need a V in the form of T. Okay. Why don't you make a plot? Trust me, plot is not easy. Make a plot for me. So what I want from you is, why don't you tell me with the y-axis as S and with the x-axis as T, make a plot. And the plot should agree with our intuitive guess. Question? I can answer. Question? No? Sure. It's going to be
increasing after a certain threshold.
yes, it will be so the increase will be like increasing slope or decreasing slope? Decrease, because if it reaches a threshold, then I think you mean like this. Let's not look at this. If I were you and I have to make a plot, then I will put a t equal to 0. E power 0 is 1. So this thing will give me a 0. And if t is infinity, then e power minus infinity will be a 0. 1 minus 0 will be 1. So as one of the students said that it will reach a threshold, I will just make the threshold like this. Let me make a very nice color line. Threshold line, as one of the students said. Okay, fill in the blanks. Okay, this is the part where I struggle with the whiteboard. Come on. Come on. It will be like this, like this, like this, right? Reaching it. Okay, what will be this threshold line? V naught over K, right? That was a good answer. V naught over K. Now, does it make sense? So intuitively imagine this. Sudden V naught, because of you're traveling, there's sudden bump, sudden V naught initial condition. Okay, it's not a forced system, it's not a driven system. Look, there is a difference. This is a bob, right? Rigid rod. Okay, I take the bob like this, and I leave, and I leave 10, 10, 10, 10, 10, 10, 10 T. So when I take the bob like this and I leave, the only thing that I'm giving to the system is kind of, yes, initial condition. And what is the initial condition? Taking it to 30 degree and leaving it. Correct? Let's do it one more time. I take the bob. This time around, I give it a push. That push now, apart from the initial condition of 30 degrees, I'm also giving 2 degree per second of velocity. Theta dot, I mean, sorry. Initial condition. Let's do it. Another case. This is the bob. This time around, I just give it an initial push from here. So this time around, I'm not taking it to 30 degree, but I'm giving it an initial push. Is this system a forced or a driven system? No. Every time I'm just giving it an initial condition. It becomes a forced system if I tell you that I am holding it with the hand and I keep on driving it. So this plot, does it make sense? Oh yeah, it does. So the piston goes like T, T, and then it just stops. So that's why initially the piston really covers a lot of distance. And then you know what? The increase of distance just kind of diminishes. 6, 5, 4, 3, 2, 1. Next task, this time you will definitely do it. Why don't you please help me with express the velocity of the piston as a function of position. This time around, I really want to see how you want to see yourself. Do we switch off from here? This one, right?
This is it.
Oh, yeah, A equal to minus KB. You got that. No, I'm not. You know, what do you do? I think you substitute that. But you substitute it instead of B, you substitute this. And it will instead of A, you substitute the KB. That is the B of the minus B. It's correct. This is the answer. Yes. So it was correct. It is correct. It is correct. This is correct. Yeah, both of you have reached the answer. Yeah, because it should be a straight line. Yes, you are right. ADS equal to VDV. Instead of A, there are a lot of students who are correct. They said, let's put a KV, and then they substituted VDV, and then they took the DS. Huh? Yeah, no, did I make a mistake? A equal to minus KV, so V cancels with the V, and we have minus K integral ds. S1 is 0. S1 was 0, right? To S, because my reference line is in my hands. Nahin? So I think we can go for a break as well. Is equal to integral dV, V1 to V2. But I think V1 is V0, we decided. And V2, I think, can be a simple V. And we have minus K S equal to, so integral dV will give me a V, because integral of 1 is a V, right? So V0 to V. So delta V, yes, you are right. Thank you. Good. Minus K. Done. So plot, why don't you make a plot? Okay, let me help you. What is the plot I want? I want a V on the y-axis, and I want an S on the. So any student who wants to talk about this. This delta V is V minus V0, right? So just keep this in mind. Okay, what will be the curve?
Start on the negative
Uh-huh.
side. V0 is 0.
V0 is not 0. V0 is not 0. That's the initial condition. So my intuitive feeling is that when you have S equal to 0, like it's V0 is given, the piston starts the journey. So your S is equal to 0, right? So your V will be equal to V0, right? V will be equal to V0. And then think about the final velocity. What is the final velocity of the piston? 0, right? Like a 10, 10, 10, 10, 10, 10, 10, 10, 10. So I have, is it a straight line? Oh, yes, it is. Boom. This is a little confusing, but that's the way it is. Make sense? Okay. Okay, everyone. Do you want me to continue, or do you want us to have a break? Really? Let's have a break then. 11:39, we are meeting again. Ahmad, Muhammad Hashir, Tahshin Chan, we have a break.
ST for S2, right? Because of S1 is 0.
S1 is 0.
and
So
S2 will be
instead of S2, I started using the word S. Yes,
Correct.
precisely.
सर यहाँ पे अगर मैं इसको इस क्वेश्चन से स्टार्ट करूँ A equals minus KV और फिर यहाँ पे इसको रिप्लेस कर दूँ कि A को dV over dt से और B को dS over dt से dt कैंसिल कर दूँ
dV by dt is equal to minus
K V actually A equals negative KV की expression
okay.
अगर dV dt कैंसिल कर दूँ तो भी वही बनता है लेकिन मैं ये कंफ्यूज में dV dt कैंसिल होगा
बड़े यूनिक से तरीके से कहना लेकिन ये होगा
A equals negative A is dv over dt and d is ds over dt. dt cancelled, so we get d change in the equals negative change in the.
this is this is correct, but it's such a unique method. I wonder whether A is equal to dv by dt equal to minus k ds by dt, and then you got a delta v equal to negative k del s A equal to negative. This is correct, and you got the same thing, right? This is correct, but this is correct. Although a rather unique.
How many minutes we have?
Five.
Fine.
One is already gone. 5 minutes. We are meeting again in 11:39.
Around.
Yes.
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 Is it close? Or I made a mistake.
Yeah, you did. I can see that. Okay. Expression v equal to function of position. Then you use ADS. You put the v. I can see that. Got it. I want to see that. Minus k s2 minus v2 minus v1. That is correct. Minus k s equal to v2 is equal to this. Then we have v as a function of position. Then we have where did you go wrong? Minus k is equal to dv is v2 minus v1. Then you have v2 as this thing. Minus v1 is v0 minus ks, and then v. Okay. v0 is equal to v0 into. Okay, this is wrong because v2 is equal to. No, we put the limits of 0 to t as well. I think it's not final answer. Okay, we have another question as well. Okay, hang on. Where is v? First, I will find it. V is equal to v0 e power minus kt. Really? Didn't I? Okay, you are right. v0, and this is v0. Oh yeah, then. Yeah, I will tell you the problem. The problem is that you have to express the v as a function of position, and this is v0 and this is v0. So what you are getting is you are getting the change of position in the form of initial velocity. We want to find how the velocity is varying, because if you see, you get my point. Velocity is just changing at every second. What expression you are making is the position as a function of the initial velocity. This is initial velocity, this is initial velocity. That's why the answer in itself makes sense, but this is not what I asked.
I need to finish your answer. I have to agree with you. This is unnecessary.
Yes. Oh yes, exactly. Here you have the same answer as well.
Yeah.
Okay. Yes, please.
So how are you?
Good.
So I have a question from the previous lecture.
Please.
So you gave an example of the electron's velocity and you gave an acceleration and a function of
Position.
So that's everything is fine. You asked for V2.
Yes.
But additionally, you gave an example of how we can find out T.
Yes.
Remember?
I remember.
Okay, so I get everything, but the thing is, I think we did the integration wrong.
We actually even did not do the integration.
But no, but not like the final part. The part where we're supposed to get velocity as a function of position, because we have to use, for delta t, we use v equals ds over dt, right? So we reposition the form equation and to get delta t on its own. So we need we have ds here, so we need s here.
No. I will tell you. So actually,
So we need function velocity as a function of position.
absolutely.
So we took the previous
Yes.
say in the case 2.
Yes.
So we found it, that's cool, but here I think this is wrong. Because so we said 4s, extension is a is equal to 4s. So it's going to be 4s here, normal integration.
Over 2. Yes.
And here, when we have position, this has to be the correct one.
Yes. I will tell you how. Look. No. This 1 over 2. No. I'm right actually. This 1 over 2 will go to the right hand side.
Uh-huh.
This 2 will cancel with this 2, and you will have 4s here. When you take a square root of 2, you will get a 2 outside. So actually this is not wrong.
So this should have been the, how is this then?
I will
found, so here, I did this one. Square, this.
okay.
So this
2s
one
here.
is square.
Okay. Now put a bar. Put 0.1 to s. Very good. Now what you do is take the 2 on the right hand side. Write it v square equal to 4s square. 4s square. No, remove the 2 before. Good. Now write a bar. 0.1 to s. It's the same. Got it? So you now what you do is substitute instead of s. You will get what I wrote here. Because even you can follow me right now. 4 into s square minus 0.1 square, but then you will have to take a square root to get the v, and this 4 will become 2.
So you did it by simplifying.
I just skipped a step and
How
then
are
I
we
did.
supposed to do this one? I have no idea.
Integration.
But this is like, we haven't, I don't know how.
No, I that's why I said if you can do it yourself, that's fine. But in an exam setting, this sort of complicated integration. Oh, of course, because all of us or all of you, for example, studied that way in some maths class. So I'm not gonna put you in a puzzle with these integrations. Just do it on your own if you can. In an exam setting, you're definitely not being judged on something like this integration. So, for example, in an exam setting, if I give you this question, if you arrive till here, you are getting points for it. And, you are getting points for it. The last step is the integration part. That if you don't know something as complicated as this, not something simple. Okay. No worries. Okay. So, Ahmad, Muhammad Hashir, Tahshin Chan. You can hear me, right?
Yes, Ajay.
Everything is fine?
Yes, so far, yes.
Oh, great. Great, great. Okay, where are we then? Now, should we start? Okay, so far so good. Life is good. Now, just quick comments. And that comment is that, oh, what happened? This is whiteboard. Okay. We have total 5 variables, okay? One is delta t, one is delta s, one is initial velocity, one is final velocity, one is acceleration. Now in a problem, you will have 4 variables. Again, this is physics 1 stuff, but I will make some problems right now. In that problem, in any problem, 1 will be the unknown. Okay. What do we mean by that? Okay, let me. So in total, these are the 5 problems in these examples. 4 variables will be the one that we will have at our disposal. 1 will be unknown. And you will be using the appropriate formulas. Okay, I'm definitely going to the next slide. Example, quickly. And you do it yourself and tell me how are you approaching the problem. The problem says I have some person riding a bicycle. Is this a point mass problem? Oh, absolutely. This is position as a function of time, and that's time. And the problem says that the plot is given like this, nice and beautiful. Okay, again, the part where I struggle with the whiteboard. Yeah. So just make a curve like this. And then I will make a straight line like this. Then I will call this as my A. And I will call this as my B, A, B. The question says, so you are not familiar with the British system, right? I will just give you a very brief introduction, so don't worry. 100 feet. And for example, in the previous semester as well, in an exam setting, I never ever gave a British system problem. So if you want, we can have this rule as well, that in an exams formation, exam means midterm 1, midterm 2, final. I will give you a system international problem because I see that everyone in this university follows that. So don't worry. But in an, oh, what happened? Chat message? Yes, please, sir. Oh, I think you said yes, please. Yeah, of course. Okay. So in an exam setting, you will get, but in homework assignments, I can keep throwing some British units so that you get familiarity. Now, this bicycle ride arrives at this location and nice and easy 500 feet. Okay. Is it visible? Okay. It's barely visible. Let me change the color, please. I don't want you to get confused. 500. Okay. And now this is 30 seconds. Why don't you all do this problem now? The problem says that this initial curve is in the form of, I am the one who is telling you, S equal to KT square. Again, it's a horrible job from my side in terms of making this line. You have to make it a little more non-linear, okay? And this part is S equal to MT plus B, right? The question says, find the velocity, find acceleration. First of all, I want a response from you. What do we need from this question? How should we even approach this? Seems confusing. In parts, right? So the journey A and journey B are completely different. You tackle the part A for velocity, then tackle the part B for the velocity. You tackle the part A for the acceleration, then you tackle the part B for the acceleration. And as for the S equal to KT square, who said that? Of course, the person who made the problem is the one who is telling you. If someone does not tell you the shape of the curve, you cannot even proceed with the problem.
For VT, you will get two equations, right? Different for A and B.
Absolutely. So your VT will be equal to an equation, and in the bracket you have to write for part A of the journey or for the curve A. And then again VT equal to something for B portion of the journey. AT, same story. Okay. Anyone who has started this problem? Okay. Let me at least help you with this. I think all of us agree that the S is equal to KT square, right? So what is the first step? Derivative, but K, what about K? You already found that one?
Yes.
I think you are right, but I will double check. So the way is that I have 2 points. I have to use one of the points. So let's use S at 10. Okay, don't make a mistake. This is at t equal to 10. So anyways, equal to, what is that? 100 feet equal to, I think you are right, K multiplied by 10 second square, which is equal to 100 feet equal to K 100 second square. So K equal to 1 feet per second square. Is this acceleration? Huh? Yes. How many say it's the k that we have found actually is the acceleration for part A. Okay, we have one. Any other student who says that? Two. Okay, so my answer is that okay, we have a thumbs up from Hashir as well. Actually, we cannot say that for now, but I will tell you why. So right now we will just, oh wow, feet per second square looks like an acceleration, but we are not sure. Okay, I will tell you why. What you will do is you will just follow the basic methodology that S is equal to 1 feet per second square, then t square, right? And then you will stop. This is S. Okay, tell me what will be the velocity? 2, right? Yeah, good. So it will be 2. Let's take a derivative. I will just do it the long way. ds by dt equal to 1 feet per second square d by dt. Okay, let me skip some steps. So I will have a 2t and then dt over dt. So as one of the students said, it is 2t. 2 multiplied by t. Okay, this feet per second square is just floating around. Anyways, right now I'm just leaving it. Or if you want, I can, okay, let me be careful here. Let me write it for you, feet per second square, then t. Okay, what will be the acceleration? Okay, now tell me the acceleration will be dv by dt, right? Equal to, what will be the answer? 2. Okay, 2 feet per second square. Okay, let me go step by step. This is for part A or part B? Part A, right? Part A, okay, of the journey. Where is the velocity? This one. This is for part A. Now tell me what is the acceleration? 2. Wow. And what was the K? 1. So which is the acceleration? 2 or 1? 2. Then what about that 1? It was a constant. But what is the reason of this confusion? Why am I getting feet per second square? Because it was very confusing, right? The moment I saw that K, I wanted to stop. I will tell you the reason. The reason is very funny, by the way. Look, you remember that? Okay, hang on. This is a constant acceleration problem. All of you agree with me, right? Yes. Right. So let us do this. S equal to VIT plus half AT square, right? Okay. When I am just explaining the reason. A problem you have already solved. When t is 0, what is the V? 0. So follow with me. This term goes right. Okay. Actually, what is happening is that, do you see this half A? Right? Okay. Now where is that K? Do you see this KT square? Do you say this KT square? This K is half of A, and it was very tempting for us to just write it as A. So this is actually a conceptual reason of why all of us were looking at this K and thinking that it is A when it was actually not. Clear? So the problem was very straightforward. A, you had to find the K. B, you had to find the V. C, you had to find the A. So you kept on taking the derivatives. Why don't you do the leg B then? Or do it. Simple, right? Sorry?
I've done it.
You done it? Okay, just tell me what is the...
M is 20.
Okay, you already did that. M is 20. And what about B?
Minus 100.
100. Okay, we will let everyone else actually finish this, then we will proceed. I will actually help. This is what you do. My suggestion is that for leg B, if you want to find the velocity, you need to have S. Now S is mt plus B, right? You need M and you need B. My suggestion is that instead of S, you put 100 instead of this T, you put the 10. Then you take the next point. Take the 500 and take the 30. So you will have two equations with two unknowns M and B. You find M and B, then you have a beautiful expression of S. Then you take the derivative, then you take another derivative. This word 100, right here 100 equal to n multiplied by 10 plus, then write a b. Okay, then write one more time. This time around write 500. 500 equal to m multiplied by 30 plus b. Which is one, solve the m and b for you. Okay, let's do it together. So we have, oh, should I go back? Okay, S equal to mt plus b, and I have leg B, S equal to mt plus b, SS 100 feet equal to, this t is a function, m multiplied by 10 second plus b. Then you have 500 feet equal to m multiplied by 30 second plus b. Then you subtract and you have 400 feet equal to m multiplied by 20 second plus 0, and m comes out to be, I think you were correct, 20 feet per second. And then you start substituting S for, no, we have to find now, so you can plug it in one of the equations. So we have 100 feet equal to 20 feet per second. Any equation of your choice, okay? Yes, no? Multiply by 10 second plus b. Okay, b comes out to be minus 100. Yeah, I think and units, feet. It's unitless.
No, units are feet.
Then where did I go?
Seconds cancel out, feet don't.
Okay. Oh yeah, sorry. Yeah. Sorry. Second goes out. That's why I was like, what is happening? So B is this one. Okay, done. So what is your S subscript B? It is 20 T minus 100. Okay, done. Everyone is with me? Yes, no? Okay. So probably, just so that no one gets confused, why don't I go back for a second? Why don't you also put A here? I think we don't want any confusions, right? So that you always remember that leg A and leg B are different, right? So A, okay, I think I put A everywhere. Okay, everyone, I will put a B here and done. Okay, quickly, tell me the velocity then. So VB, okay, function of time equal to 20 feet per second. and then A will be, okay, it's not even now a function of time, but anyways, it will be 0. Done? Yes, 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 yes. Anyone who came close to the point? Okay, good. Graphs. You tell me the graphs now. So this is what I want. You remember S versus T was in the question, right? You make a V versus T, and then you make A versus T. So you have S versus T that I gave you. You make a V versus T right below it, and then make an A versus T. Do we have anyone who is, what happened to this one? Oh. How do we remove it now? This computers are, this one?
Click to finalize button.
Okay, this one? This one?
Lower part. No.
Okay, sure, okay. Okay, good, thank you. Okay, so just so that everyone is with me, 7, 6, 5, 4, 3, 2, 1. This one is important. You are doing it yourself. Okay, this is what I gave you. S versus T. Okay. And this is what I asked you, that this, it goes like non-linear, nice and beautiful. And then it goes for a straight line. Okay. Then this was, okay, this is just horrible drawing. Let me connect it. Okay. Then I told, again, bad drawing. Come on. Ah, better. This is A. This one was B. And then I told you this one was 10 seconds. This one was, what was that? 100 feet, right? 100 feet. Then I told you that this fellow is 30 seconds, I think. And then this fellow was 500. Boom. Done. Now comes the $1,000,000 question. What will be the VT curve? Use your imagination. Think about it and tell me. Okay, what is your response?
It will be straight line, start from the 0, right?
Yeah, he's right.
It will be goes.
Yeah,
20.
good. So I would suggest that we go back, look at the part A. SA equal to, VA equal to 2T. Where is it? No. Yeah, VA is equal to 2 multiplied by T. So I will write VA equal to 2T. I agree with you. And I will put a straight line as per your suggestion. And I will go till here. And I will make a dot here. Then I will go back and then I will look at, where is it? V of the B, that is 20. That's constant velocity. Please focus here, please. For the leg B, it's constant. So what should I do? Horizontal line, right? Oh, it happened. So I have, this is 20. Okay, I have a quick question though. What is my question? Okay, I wanted to ask a question. What was that? I actually forgot. So, what was the question? Okay, never mind. So let us have this one.
For the A part, I think it will be 2 feet.
Did I write 20? No, 2 feet, you mean? Okay, let's go back. Part A. Yeah, velocity is 2 multiplied by t.
So, okay.
So that's why it's a linear line, right? 2 multiplied by t. Okay. Yeah, I think I wanted to say this thing. What does the area under the VT curve tells us? That's what I was thinking. Is delta S, right? So let's have a different perspective. VT, so for this leg, what is this showing us? It will be 1 over 2. Okay, let's do it together. 1 over 2 multiply by area under the triangle, right? 20. What is time? 10. Okay, what is the answer? 100. So 100 feet I am getting. Okay, so area under the curve you said tells me the distance covered, right? So am I getting 100 feet from this curve? Yes, I am. Am I covering 100 feet? Yes, I am. So everything is making sense. Okay, last but not least, why don't you all help me with this part? What is the area under this curve? Okay, area under the, okay, he said 400. Okay, you are right, I think. Let us make it. This is 30. This is 20 multiplied by, this is 30 minus 10. So 400. So if I have distance covered 400 here, so 400 on top of 100 will give me a 500. So it makes sense. Okay, last but not least, should I repeat it? It's fine. Are you sure? Okay. Because I thought that everyone is getting, so I just kept on going. Okay, why don't you help me with this one? Okay, this is difficult. Tell me. First, I will do like this. Boom. That's a 10. That's a 30. Oh, wow. So, no, I will go back actually, because otherwise it is hard. So acceleration for leg A is 2 and acceleration for leg B is 2 and 0. So 2, oh, where it is 2 and then 0, done. So I think the question actually ended before we even started. Right, done. Boom. 2 feet per second square and 0. Okay, important question. Is equal to dv by dt. What does the area under the acceleration time curve will give me? Huh? Change in velocity, a equal to dv by dt, a multiplied by t. Okay, so let's put it to the test. 2 multiplied by 10 will give me the change in velocity, that is 20. Was the change in velocity 20? Huh? Right? Because it goes from 0 to 20. Makes sense. Okay, what about area under the curve here? 0, right? So there was no change in velocity. Done. It's clear? Everyone? Sure? Sure, right? Do you want me to make another of such problems? Really? Okay, let's do it. So new problem. This time definitely you all are doing it. Okay, so do we have any questions, comments? Sure. Okay. So I told you that I am the one who gave you the kind of curves in the problem statement. No? Okay. Okay, I will make a quick problem for you. This is a new problem and you do it. We have 20 minutes. You can all do it. The problem goes like this. Let me use a nice and beautiful green marker. If we were 100% online, this would have been a really nice quiz, no? But we are not 100% online. It's like hybrid. Okay. So let me put a bracket T and we have a T. The question says, again, some point mass car or whatever. It has an acceleration like this. Then we have, okay, the question says that this is more like a test car and the car eventually stops. The car eventually stops, okay? Please, so keep noting these things. It starts off with a nice and beautiful acceleration of 10 feet per second square. And it goes till here up to 10 seconds. And this is T final that we don't have any idea. Now, as I said, it goes till it stops. So TF, we don't know. Now the question says, find, make V versus T and, oh, what happened? S versus T plot for me. Also tell me the TF. Now I'm telling you, it goes until it stops. So the car doesn't start to reverse, okay? It goes as long as it just stops.
What is the value of this negative acceleration?
Yeah, I forgot it. Yes, good. It was a good question. -2. Thanks. Because otherwise you cannot proceed. So, in fact, I will help you a little bit. Y-axis is A. Oh, what happened? A. X-axis is T. Yes, no. And I will put a yellow marker. This is how I am helping you. Think about it. So I will write in the notes, the car eventually, test car eventually stops. Find the TF, then VT, T curve, and then STT curve. Starts at rest, right? It starts at rest. Yeah, that's important information that I forgot. Starts from rest. Oh, I will just squeeze in the plots today, you know. Okay. That's nice. Any student who did that. That's a V. Let me use a purple marker. That's S bracket T. Done. Time when the point object stops. TF is time. TF is time when point object stops. So anyone who has devised a strategy?
I've done 60.
How much time?
50 seconds.
Total is 61.
Total will be 60, right?
Yes.
Okay, so I think the way he tackled this problem is
Finding velocity.
because area under the AT curve will be change in velocity. So if it starts from rest, then that means 10 multiplied by 10, the change in velocity will be 100. And this area under the rectangle will also be 100. So I think the strategy goes like this. 100 equal to, you start from 10 TF minus 10 multiply by this height, which is 2. Did I? Okay. 50 equal to, oh, what happened? Oh. So it is 50 plus 10 equal to TF, right? So TF equal to, did anyone else did the same thing? No? So then I, instead of writing TF here, will write 60. So now I will write nice and beautiful 60. Nice and beautiful 60 seconds. Okay, what about the VT curve? So it starts from rest. So I have a 0 here. So what about if acceleration is constant? Okay, what should I do?
Straight line 200.
Straight line, right? And you figured it out because dv by dt is constant. So slope of the line will be constant. That's why you said that. So I agree with you today. Good. And then there will be -2. Slope will be slight. So it will go like this. Okay, that's just horrible drawing. I just wish I had more space. I would have made this like this, but I don't have space. So but in any case, it is visible that this slope is big and this is small. So I will say this slope is -2 and this slope is, what is it, 10? Okay, anyone who wants to contribute to this S versus T?
One leading rate
Huh? Increasing
and then decreasing.
and then decreasing? Yeah, I think you are right. Let me comment on that a little bit. So how did you figure it out? Like this? Like this? Like this? Yeah, but how everyone figured it out? So I think you figured it out because okay, so this V is 0. So if V is 0, then ds by dt is 0. So ds by dt means the slope will be 0. So I will start off with a 0 slope like this. And then as V keeps on picking, this means ds by dt keeps on picking. This means my slope will keep on increasing. I think this is how everyone arrived, which is pretty impressive because it's not straightforward. Then you can see that the slope starts to decrease. So I will have to make a decreasing slope. Then the slope becomes 0. So I have to arrive at a 0 slope. That one was hard, by the way. But anyways, I'm pretty impressed everyone got it. So, okay, I will try to arrive at the same finishing point. So here, yes.
So for interruption, but we did calculations 100 equals TF minus 10 times 2.
Yeah.
So it starts from rest and it will go over rest and until the 10 seconds it will get velocity and in order to come to rest again the same changing velocity will be equal. So because of that we do this calculations. Right?
Okay. We are talking about this one, right?
Yeah.
Because the question said that it starts from rest and the car eventually stops. So what will be the TF? So our point is that whatever change in velocity, it goes from 0 to some value. You need the same change in velocity in the negative sense at the end. That's why I equated this rectangle with this rectangle. So I had 100 equal to TF minus 10 multiplied by 2. But again, I think that this curve is not 100% correct, but I think you get the point because it keeps on increasing till here. So probably I would have kept on, then I would have decreased. But anyways. Okay, any questions? Everything is fine, right? Sure. Yeah.
Also the curve changing
The curve changing?
in 10 seconds.
Yeah.
Because the velocity will be decreased and velocity equals to the S divided by dt.
Okay, yes. So my point is that velocity is equal to ds by dt, right? When we have a velocity that you can see it keeps on increasing, that means ds by dt keeps on increasing. Now ds by dt means slope. So you see slope is 0, slope increases, slope keeps on increasing, and then the slope goes to a maximum, and then it decreases. So this is why you can see beyond a certain point of time, the slope also wants to decrease. Okay, 6, 5, 4, 3, 2, 1. Why don't you do this problem? This is your very easy problem, and then we will say goodbye. The weekend starts. Okay, this is some city board. We have a car, point object, car. Okay, it is at a certain distance from the city, that is 100 meter. Okay. The question says that if it has an acceleration of in this direction of 5 meters per second away from the city, okay, and the v1 is 0 meters per second, find the position when the velocity is find the position when the velocity is 40 meters per second. Okay, first of all, is it a constant or variable? Constant acceleration, right? So constant acceleration means I'm going to physics 1 formulas. So do it. You got it already? Yes. Do you want me to write the formula? It's straightforward, right? Okay, then since I think it's straightforward to many students, I will just write down the answer. I think 2as equal to vf square minus vi square, and we have 2a into s2 minus s1 equal to 40 square minus vi square. Vi is 0. Did I talk about that? Yes, I did. So we have 0 square, and we have S1 is 100, so S2 comes out to be 260 meters. Just one quick question I wanted to emphasize on your physics 1 as well. And you can also find time it takes for velocity to reach 40 meters per second. So that is S equal to delta S, yeah, delta S equal to VIT plus half a t square, and that is delta S is 260 minus 100 meter is equal to 0 plus half a t square, and your delta t comes out to be, you can do it. How much? 8 seconds, right? Delta t or t comes out to 8 seconds. I intentionally did it because if you keep on going for complicated problems, yeah.
So in the previous question, you were trying to find final time.
Sorry. Oh, absolutely. Yes, I should have said that.
You're trying to find final time, right?
Yeah.
With this constant acceleration equation. So we find one minus v over. Are you supposed to get it from here? Like, why did you use this area as?
Oh, you use that. This is good as well. So you use
That's
this
the
one.
question.
Very nice. You can surely use that. Vf minus vi equal to a delta t. So
Because we're trying to find the objective of here. And we need to use the acceleration here.
yeah. So what did you put in your Vf minus vi?
10 times 10 for this area. That's what we did.
Oh yeah, I know. So my whole logic was that the car starts from 0 and it goes all the way up to a certain acceleration and up to a certain velocity. So if I'm saying that that car now will have to stop after a certain time, this means whatever increase in velocity that car had to be reversed. So I'm going from 0 all the way up to 60 kilometers per hour, let's say. If I'm saying that it has to come to a stop, then it has to go from 60 to 0. So at the end of the day, A is equal to dv by dt. So A multiplied by t is nothing more than the change in
So
velocity.
this is actually 0 minus 150 because of time. It has to be positive.
So exactly what exactly. So 10 multiplied by 10, 100 is the
Assume.
10 multiplied by 10 is area under the 80 curve. So 10 multiplied by 10 is the change in the velocity. That's why this 100 is the change.
Okay. So normally, without any assumption, we have to calculate this area for this.
So no. So what I did is I just
Normally.
normally.
What is
So for example, this area under the curve
it has to be minus 2
multiplied by TF minus 10. Exactly.
And then we have to calculate. So because we need TF.
I equated that with the top area.
And then just do normal algebra.
Yes, I equated it because the change in the velocity is equal to the change in the velocity. How much it takes from here to here is the same change in velocity I require from it to go to from 60 to 0.
So that's just an assumption.
Not even an assumption. That's actually a fact that if I have to go from 0 to 60
So
kilometers.
if I calculate this area, I will find 100 again.
Yes, if you.
Oh, sorry, not 100. T final as the same. Sorry.
Of course. So I equated these two areas actually. Okay.
Thank you.
Okay. Yeah. Welcome.
When are you going to upload the presentation? I mean the lectures.
I didn't post the previous one.
This one?
This one probably today in the evening. Did you watch the previous one?
No, actually I checked it like 2 days ago. It wasn't there. Maybe you uploaded yesterday.
Google Drive. Google Drive. The moment I sent you the email regarding Google Drive, lecture was available. No? Okay, please and let me know if you can't find it.
sadece bir yani yapsın ya. Ne kadar şeyler var ya. Yapacağız başvurular var. Yapacağız 800
Kendi doktoranından olur.
yani
Ahmed, Hashir, Tashin Chan. Okay, everyone. Bye bye.
bir şey var işte. Akşam dersi var.
Bye, hocam. See you.
Akşam dersi var. Bizim dersin çıkışına belki gideriz de. Var ya bunun süper var ya.
Yani
Ansys problemi.
Thank you. Bye bye.
Onun dersi var kanka. Ben kaç kere bir